recap in class. So hopefully you got all these notes down and you're ready to go. But we're talking about volcanoes on this one. So volcanoes are basically isolated locations of magma in the crust. I know you don't have it written down yet. I'll go back to it. So here we've got an situation. What kind of boundary is this? We've got movement going toward. We've got a subducting lithospheric plate. We've got thicker continental, less dense continental, even though it's thicker. Maybe I should say thicker. Maybe I should say deeper. We've got an oceanic trench being created here offshore. We've got melting of this material here in the asthenosphere, bubbling up magma, creating a mountain range of volcanic. So this would be a convergent boundary, coming together, convergence. But they're isolated locations in the Earth's crust where we have magma, because we don't have magma pretty much anywhere except in these locations. They occur from divergent, convergent, like we have here, and also something called mantle plumes that we haven't covered yet. We also call these synonymous with hotspots. They occur in concentrations along plate boundaries, and also you should probably know, although I'm not sure that they said this for sure that you need to know this, but you should probably know what the Ring of Fire is. So if they're talking about the Ring of Fire, you should probably know what that is. It's not actually fire, it's a ring of volcanoes that surround the Pacific Ocean. Now this happens because we have a bunch of convergent boundaries creating oceanic trenches, and more importantly, having subduction, which is causing melting, which is causing volcanoes. So now we actually have some divergent boundaries here, the Cocos Plate and the Nazca Plate as well. But here at the South American Plate, we have the Nazca Plate at this boundary actually merging, subducting, and then melting, creating these Andes Mountains here. We've got mountains being created here. Technically, we've got a small transform fault there, but then we have Washington and Oregon. We've got the Juan de Fuca Plate kind of being eaten and recycled back under there, melting under here. We've got the Pacific Plate causing a massive Aleutian Trench here next to the Aleutian chain of islands connected to our state of Alaska. We've got trenches lining here. We've got an island arc being created, which we call Japan. And then we have the Philippine Trench. We have all this. We've got the Marianas Trench. Oh my goodness, where is it? It's hard to tell on this map, but it would be somewhere over here, the Marianas Trench, the deepest trench there is. And then we've got all of this other stuff too. So the Ring of Fire, again, sorry, not fire, but just a bunch of volcanoes dotting the Pacific Ocean. Now what we have here, we have a magma chamber down below. The magma, when it gets hot enough pressure, will find places where it can extrude into. So here, you don't need to know what a sill or a dike is. You don't need to know any of those. If you learned them last year, laccolith or a batholith, that's great. I don't think you need it for this test. So if you're trying to rememorize that, don't. So we've got a magma chamber. It wants to go to the path of least resistance. So if that's sideways, it goes sideways. If that's up, it goes up. If that's the side of a volcano, that's the side of the volcano. It goes wherever it can. All right, so an active, dormant, and extinct volcano. What's the difference between the three? An active volcano is one that's erupted in the last 10,000 years. A dormant volcano is one that's thought to still have a magma chamber, but hasn't exactly erupted in the last 10,000 years. Sorry, 10,000 years. An extinct volcano is considered unlikely to erupt ever again. That says every. You should write ever. But an extinct volcano is just one that we think the magma chamber is either solidified, so the liquid magma has become rock. Magma chambers shift sometimes. The heat becomes more intense somewhere else. So the heat change could change. For whatever reason, that magma chamber is no longer functional or existing in that location. So we have three types of volcano that we're going to talk about in this class, and that's going to be shield volcano, a stratovolcano, volcano, which we're actually going to call a composite volcano, and then a cinder cone volcano. Now, shield volcano, we have some of these up in Tremonton. If you've ever been up there in Tremonton, a lot of this type of action going on when you drive up to, what's it called? My gosh, Idaho, the state above us. We have a lot of these action. Basically, you look at them, you don't really think of them as being a giant volcano unless you get really far away from them. They tend to be wide. They tend to not be very steep, like a shield. Maybe that's why we call it a shield volcano. Gradual slopes. They typically erupt pretty slowly. Sometimes they'll have fissures, sort of shooting lava out, but they have very low viscosity because it's the highest temperature magma that we have. It will be bubbling out basaltic lava. This is what you see when you have that really black lava rock. This is what we're talking about. Sometimes that red lava rock, depending if there's iron in the magma chamber. Yeah, that's all I have to say about this one. So examples of that would be Mauna Loa in Hawaii, Mount Wrangell in Alaska, and this one I'm not going to pronounce in Iceland. Yeah, not going to try. So here, this is what we typically have. Right here at the eruption point, this fissure, this is not actually the caldera, but here's a fissure erupting. You can see that it's coming out forcefully because of how fast this appears to be moving, and it's coming out really, really hot. Now, usually, once it leaves this area, it's flowing not as fast, very, very slow, and it cools off pretty rapidly because it's coming in contact with the atmosphere, and again, it's not flowing very fast. So you can actually come pretty close, not to this. This, it would be so hot, you wouldn't be able to stand next to it. But, go back to the video, please, Fezzy. But in the video here, you're going to see this guy get really, really close. Now, this would be going too fast, too hot. But you're seeing on the it's no, it's not typically so enough that you know, I'm not seeing pretty here. Pretty, it's really good. Just in those get started there, and this just 50 definitely so we around 500 here, but not sorry, like to image looks like the water that cool. Now this video, this is a show an eruption 2011 on Hawaii. We don't have fish of this stream off, but it's still nearby. Like just actually so here then a lot more magma sure is what's between the mag is the lava is Alright, let's go ahead and go to the next slide. So composite volcano, this is also known as a stratovolcano. I believe on the test they're going to call it a composite, but just in case, no, a stratovolcano and a composite volcano are the same thing, they're just different names. It's usually tall. This is what people most of the time think of when they think of a volcano. So Mount Fuji is a stratovolcano. Mount St. Helens, I believe, is a stratovolcano. These are the things that you're used to erupting. Now, sometimes they can ooze out, like the shield volcano we just saw, but a lot of times they can erupt extremely violently, and when their eruptions are so explosive, they can knock down entire forests nearby. The amount of explosiveness of that volcano is going to be determined by how much gas is inside the magma chamber. Now the other volcano, the shield volcano, that was going to be primarily basalt rock, that really black rock that you see, that you're used to seeing. This is going to give andesite and rhyolite, sort of gray rocks with bands, if you guys used those last year. Some kind of red mixed rock. Basically, we get some gray rocks. Now sometimes we can get small crystals forming in these as well, but for the most part it looks like someone mixed a bunch of clay together. Or sorry, Play-Doh together and made a bunch of different layers. So examples here, these are already written for you, but we do need to memorize these for the test. Mount Hood, Cotopaxi, St. Helens, Fuji, Lassen. Make sure you're getting these and where they are located. So Mount St. Helens is the United States. I don't know if you need to know if that's specifically in Washington or not, but wouldn't hurt to memorize that too if you have enough space in your brain. Cinder cone. Apparently, these are the most common things. I did not know that they were the most common volcano. I did that when I was researching. But yeah, apparently they appear on their own as a standing volcano, but they also appear on the sides of volcanoes as well. So, I mean, sides of stratovolcanoes, because they are volcanoes themselves. So cinder cone volcanoes, eruptions of cinders blown in the air and then settle. Tend to be small, but they can be large. Steep-sided mountain. Again, they're a mountain, so they're relatively large.
But see how we've got, it almost looks like things have tumbled down the side of the mountain here. We have eruptions of things spitting out here. Spitting out is lava, and then they will harden in the air and then hit and then kind of form layers here. Now sometimes they can spit out as like ash. Now you have to understand, volcanic ash is not the same as like ash from your fire. Volcanic ash is just basically lava spit out in such small, tiny, I don't know, spews that it turns into flakes in the air. It solidifies in the air as tiny little flakes and it comes down. So we can get a bunch of layers like this of rock floating down and making this, and in larger sections making that as well. Examples of this: Mount Mazama in Oregon. The collapsed, you might know this better as Crater Lake, because that's the collapsed caldera is actually the location of Crater Lake. I don't know how to say Paricutin in Mexico, I'm guessing. Mount Shasta in California, that's Northern California again. And I don't know how to say this one either. Cerro Negroin, I don't know, in Nicaragua. All right, again, we'll do recap in class. Now, I believe this is where the next video starts, so I'm going to stop right there.